All right, this is APAB Calculus, and we are doing the midterm review. This is free response 21C, which is the last free response on the review packet. It is non-calculator. So using the K and P we found in part A, so just as a refresher, in part A, we found that K was -2 and we found that P was 2, right? So this is actually x squared minus 2x plus 2, so we'll replace that. We are asked to find all the points of inflection of the graph of f and support our conclusion. So again, we need to start with the ask, right? So we want f points of inflection, and we have to translate that to what it means. So a point of inflection is where f double prime equals 0 or does not exist, and this is the really important one, changes sign. I need f double prime to change sign. And the trap is that routinely we have a spot where f double prime is 0 but doesn't change sign, and then a lot of people mark that as a point of inflection, but it's not. So I kind of need f double prime. Now we already found f prime, so I'm going to cheat again, and I'm going to, from part B, I have f prime, so I'm just going to write it down because we already have it, and why reinvent the wheel? So this is 2 minus 2x for x values less than or equal to 1, and this is 2x minus 2 for x values greater than 1. Cool. So that's my f prime. So my f double prime is just going to be the derivative of that, right? Now, we're not sure that this function is differentiable at 1. Like, again, we know f was differentiable. We don't know if f prime is. So we're going to have to be careful to not put an equal to here. So when I differentiate, I'm going to get -2 for x values less than 1. And when I differentiate this guy, I'm just going to get a 2. Well, those are definitely not equal, right? Like the limit as x approaches 1 from the left of f double prime very much does not equal the limit as x approaches -1 or +1 from the right. I said negative over here. I apologize. I misspoke. So this is a -2, and that very much does not equal a 2, meaning that f double prime of 1 does not exist, right? So that's important. Everywhere else, f double prime is going to exist. F double prime is a nice happy 2 on this side. It's a nice happy -2 on the other side. So the point of inflection is going to happen at x equals 1 for 2 reasons. Number 1, f double prime of 1 does not exist. And number 2, f double prime is negative before 1. It's literally just a -2. It's not even a variable function. It's just -2. And f double prime is positive after 1 because it's just a 2. So f double prime is less than 0 before x equals 1. And actually, if you want to write it in a fancy way and not just say before, you could say for x values before 1 would be x values less than 1, and f double prime is greater than 0 for x values after 1. Meaning, and again, if you want to be super clear about it, f double prime changes sign at x equals 1. Right, and that's what we need. So again, we need to spot what a point of inflection is, and then we need to go ahead and find that with the information we're given. But if you don't know what you're looking for, if you don't translate what you're asked into what it mathematically means, you're just going to find yourself kind of stumbling around and confused. And that's it.